This is video 1 for the chain rule. There's going to be a couple, 3 of these videos because some of these problems take a little bit and I'm trying to chunk it up for you. But this is the first one that kind of gives you a background of what the chain rule is, and I'll go through steps and we'll do some practice problems. So first of all, the chain rule. Okay, the chain rule is basically based on the derivative of a composition. So here I have h of x, and it's f of g of x. So those of you that are familiar with a composition, notice I have g of x is my inside function, it's inside here, and f of x is the outside. Okay, so I can say the function h of x is a composition of f of x and g of x. The outside function is f of x, and the inside function is g of x. So let's practice with these following functions to talk about what a composition is before we start talking about the derivative. So if I were looking at this one, and basically when I used to do this in pre-calc, and we've talked a little bit about calculus here, is we're doing decompositions here to say, okay, if h of x is already a composition and this is what it is, what was it? What two functions, how would they be in order for this to come about? Have 2x plus 1 to the 7th. Remembering up here that f of x is your outside and g of x is your inside. So let's do the inside first. And I look at it here and I said, okay, if I had parentheses here, my inside function would be 2x plus 1. My outside function would be x to the 7th. So that if I did f of g of x, whereas I put this in that x spot, I'd end up with that. So that's a decomposition. Let's look at this cube root here. Let's start with the inside. So my inside function would be 7x. My outside function would be the cube root of x, or x to the 1/3 if you will. Alright, now if you're doing exponents, okay, I'm going to do a little star here. The inside, typically, if you were to look at it, is your exponent. Okay, so my inside in this case is going to be negative 5x. My outside is going to be e to the x. So if I were to place that in that spot, I'd end up with that function there. Now, trig notation. You got to remember, if you see the cube here, that really means it's the sine of x cubed, but for trig notation, we typically move that 3 here, even though you're taking the sine of x and cubing it. This is what you're really doing. That's how the notation shows it. So my inside in this case would be the sine of x, and my outside would be x cubed. Now this is important that you understand how compositions work, so that when we start doing these derivatives here, that you'll understand what's an inside and what's outside, because that's going to help you tremendously. Okay, so let's look at the derivative of a composition. So here I have h of x is f of g of x. I've got the same thing as I have above. Now when you do the derivative of a composition, what you do typically is, and this is just a basics, I'm going to show you how to actually do this, is they like to simplify this, and a lot of textbooks will call your inside function, for the sake of simplicity, a u. Okay, so u is really g of x, just to make life a little bit easier. So if I let u equals g of x, then y equals f of u. You're like, okay. Now, if you make a change, a small change in x results in a small change in u, which then will result in a small change in y. So that basically means that you have gears. Think of this as this, all right? So if I have a change in x, it will change u, and then it will change y. So it's like a chain effect, hence the name of the chain rule. So here's my outside. My outside function. This is the middle, which is your u-turns right in here, and this is your inside function. Okay, so if this gear turned here, this is going to turn this way, and it's going to turn that, so they all depend on each other. So the outside would be change of y over change of x, which notice this is slope or your derivative, okay? How we do this is a change in y over a change in u, which is your middle, is going to result in an inside change, which is the change of u with the change of x. And in order for us to do these changes, you'll notice that we're multiplying in between. Okay? So let's look at this in calculus terms. dy dx, which is the derivative of y with respect to x, is equal to the derivative of y with respect to u times the derivative of u with respect to x. And if you look at this, these would cancel and these would cancel, so you end up getting your derivative of y with respect to x. So basically, when we do the derivative of a composition, you're going to do the derivative of the inside times the derivative of the outside. All right? But there's a little trick to that, and I want to show you. So the composition of f composite g, which is the same as saying f of g of x. So here's another picture way to look at this. It is f prime of g of x times g prime of x. The one thing I want you to notice I'm taking the derivative of the outside. I'm leaving the inside alone. Then I take the derivative of the inside. So let's look like this. Here's x. I have a rate of change. At x equals g prime of x, I come to here, and u equals g of x. I have another rate of change of f. And g of x, it's f prime of g of x. So I have y equals f of u equals f of g of x. So this is another picture, all right? And we'll be showing more in class to help you. But let's get started basically talking about how to do the derivative. And then I'm going to show you a really cool picture that I found that might help you too. All right, so I call this the outside-inside rule, okay? So let's go through this. The derivative of a composition, so that's what we're doing, is the derivative of the outside function, and this is so important. Keeping the inside function the same. That is so important. And then we're multiplying it by the inside function, by the derivative of the inside function. So let's look at this in math terms. So the derivative with respect to x of f composite g is the f prime of g of x times the derivative of the inside. Another way to look at this is I tell the kids you have the derivative of f of glop. So you have something in the inside. You're going to do f prime of glop. Notice I'm not touching the glop times the derivative of the glop. All right? I have kids that get kind of confused because when they take the derivative of the outside, they will touch this. So you don't. Well, I found this really cool picture. Let me see if I can find it here for you to look at. Where it's a cartoon of someone how they learned derivatives. So this is called, they use the mother-baby effect. So you differentiate the mother. I love this. They differentiate the mother and leave the baby inside alone. So you're taking the derivative of the respect of the mother with respect to x. Then you differentiate the baby. So you take the derivative of the baby, and then you multiply them. And this is how they learn the chain rule, which is kind of cool because it makes you so you don't touch the inside. So let's find this here, and let's do some so you understand. So you basically are going to have f of your baby is f prime of the mother. So this is, and you leave the baby alone times the derivative, okay, of the baby. We'll say f prime of the baby. Okay? So you do f prime, leave the baby alone. Well, that says the same thing, doesn't it? Let's try to write this a different way. So your f prime of the baby, and you leave it alone, is g prime of the baby. Okay? So let's look at how to do this. Now the best way to do this is to start with an outside and inside, and I'm going to do some of the now you tries here, but I'm going to stop this, and you might want to stop the video, like I'll do one together and then you can try it and then start the tape back out, but I'm not going to stop, okay? So here I have this function, parentheses 3x squared minus 5 raised to the 6. So the first thing I want you to look at is the outside function, or the mother, is the power rule, if you look at it, because you have something raised to the 6th power. The inside is the power rule again, because I have 3x squared, or the baby, if you will, 3x squared minus 5. So in order to do the derivative, you're going to do this. Y prime is the derivative. So I look at this whole thing. If I was going to do this, and don't even look at the baby. So don't even look at this. This is your baby. Don't look at it. So if I was going to do the power rule, I would do 6, don't look at the baby, raised to the 5th. So now write the baby in there. Don't touch it. Okay? Times the derivative of the baby, which is going to be 6x. See how that works? You take the derivative of the outside times the derivative of the inside. And when you take the derivative of the outside, you do not touch that baby. So I have y prime. Now, when you get all done doing that, I can say, well, 6 times 6 is 36. X times 3x squared minus 5. Okay? Raised to the 5th power. All right? Let's try this one. Y equals. So what's my outside? My outside is something raised to the 7th, which is a power rule. The inside is going to be 2x squared minus 5, or the baby. So let's look at the outside. How would I take the derivative of the outside? It'd be 7, don't touch the baby, raised to the 6, times the derivative of the inside, which is 4x. Okay? Now all I do is simplify it. 7 times 4 is 28x, times 2x squared minus 5 raised to the 6. All right, let's try this one down here. The outside again is something raised to the 4th, so that's the power rule. The inside is x cubed plus e to the x. So I'm going to use the power rule for this one, and I got to use an exponential rule for that. Okay, so I do y prime. What's the outside? It's the power rule. 4, don't touch the baby, raised to the 3rd, times the derivative of the inside, which is going to be 3x squared, and the derivative of e to the x is e to the x. Okay, so now all I'm going to do is I kind of move this up front and leave that here. So I have y prime equals 4 times 3x squared plus e to the x times x cubed plus e to the x raised to the 3rd power. And you can't really combine these because they're not the same. So you go ahead and try this one. I'm going to do it here. So I'm going to do the outside, which is the power rule. So I'm going to do 9, don't touch the baby, drop the power down, times the derivative of the baby, which is 2x plus 3. And then all I do is bring that up front and leave it in factored form. Okay? Alright, I'm going to stop this video and start a new one, but I just didn't want the videos to be too long. So if you want to get started with this, I'm going to start another video and you can check it as you go along, because we're just going to keep practicing some problems.